Hello coders, welcome to my video. So let's start in continuation with the last topic of Connect, which we discussed, and we created a very basic server and client application. Okay, so in this thing, we will discuss what is a problem with the simple TCP server that is solved by using a select system call. So we'll see how to use the select system call, what are the advantages of using the select system call by having is this modification on our client server program, which we have discussed in our later videos. Okay, so first come first, so let's check out what we have done till now. So we created a simple server in which I am accepting a connection from the client, and after accepting I'm reading that client FD, and after that I'm writing to the client FD and I am closing this. Okay, simple as that. So what happen when the first client come to this accept, it will create this client FD through which your client will communicate to the server. Okay, so once this FD is there, we can read from that FD and we can write on that FD. And once it is finished, I'm closing it. Okay. So if the second, client is coming, the same process will be repeated. But the if it is reading at the first client, it will block here. It won't take it. Okay. So this is a blocking call actually. So the point here is all the clients will be interfering with this point of code. If I won't close it, there is of no use, because once the new client attack this accept, it will create its own FD and try to communicate. So once client communicated, it won't be allowed to communicate again. Okay, so this is the design of this of the server. So what we need to do now, we need to communicate continuously with our clients. So for example, I need to communicate as a chat server and client application. So I want to chat with my server. For example, client one says hi, so the server could say hi too. Okay, and when the second client comes, it won't interfere and it will also reply to that client as well simultaneously. So it won't stop one client from communicating and address the another client. So it will manage it somehow parallelly for both the clients. So for that, we need to change this design of this server. So what I need to do, we need to use a select system call. Okay, so let's go to the man page to understand what are the input and output of a select system call, what are the APIs we will be using in select system call, and what is the basic regarding the select system call. So I'll close this, and okay, so here I have different versions of select with some of the APIs, or you can say the macros. For example, FD set, FD set, FD0, and FD clear. Okay, so here is our header file that we will be using for the select system call. Okay, so here is the API. Okay, so we have one, two, three, four, five parameters to this select system call, and here we have the number of FDs. Okay, so here the number of FDs shows the number of clients to which the server is connected, along with the listening socket of the server as well. Okay, so next part is FD set. So this is an array of FD that we are going to read. So any activity on these FDs, okay, so that is represented by some client. Okay, so any activity on that FDs, this select will be triggered at that particular time. Okay, so if there are write FDs, if something is written on that FDs, so it is triggered at that time as well. Okay, some exception FDs and some timeouts things are there for this select system call. So what happen when we are using accept and we are putting that FD in read or write or exception FDs, and select call will monitor all the FDs with that we have put in read FDs or write FDs or accept FDs if there is some activity on that. Okay, so this is handled purely by the kernel itself. It will handle the the activities on that FDs, and once the activity is there, select will be called that particular time. It will come out of that sleep and do its operation as well. Okay, so there are few APIs or macros you can say you can use while using the select to input your file descriptor after the accept system call, because your access system call will give you a client FD, and every client which is connecting to this server have some FD. That thing we can put as FD set. Okay, so first we need to do zero on all the FD. So we have FD zero for that, and here we have FD set. If you want to check or set some FD, we can do it. So we can check if FD is set or not. Okay, if it is clear, we can go for this file descriptor. So this is a part of the this structure FD set. Okay, so description, if you so see, then we have select and p select allows a program to monitor the file descriptor waiting until one or more of the file descriptor be deleted for some class of IOs input possible. A file descriptor is considered ready if it is possible to perform corresponding IO operation like a read or a sufficient small write without blocking. Okay. So select can monitor only file descriptor numbers that are less than FD set size variable. Okay, and poll does not have this limitation. Okay, so here we have some description, so we won't go much into this select system call. So I will be modifying our code so that it can be connected with the multiple clients. Here is the new version of our server which will be handling the multiple clients throughout. Okay, so we'll test it. So first of all, let's see what are the changes we have done in our last program. Okay, so let's start from the starting. Here I have been listening on the port 9090. I can handle 5 clients and with a buffer size of 1024. Okay, so whatever data we are sharing with the clients, that's of 1024 bytes. And here, if you see, I have a socket um, call. Okay, I'm getting the server FD. Along with that, here I have taken an array of clients where I will be saving some clients related stuff. And I have the read FDs where I will be reading on the file descriptor. And these file descriptor will be this server listening socket and also the FDs that are used throughout the clients that are used by the clients, that all will save here. And if we go here, I am using the bind system call. I'm binding to our port 9090, listening to that, and TCP server listening on the port will be displayed here. Okay, and here is our main loop that is starting. So first we will make that array 0 by using FD underscore 0 API, and we'll input this read FDs. So see, this read FD is a FD set. Okay, so this is an array type. Okay, so here I will be adding our first file descriptor that is of the server, that is server FD. Okay, this I will be adding to this FD list first. Okay, and here I have a max FD. So here now I have the max FD of server because the FDs will keep on increasing. So whatever FD I got now, the next FD will be more than that. Okay, so that's why I'm taking this max FD as server FD for now. And here I'm adding the client socket. So the main part of this adding a client socket is to set the max FD as well as this read FDs. Okay, when a new client came. Then the next part is waiting for the activity. And here we have this select system call in which the first parameter is a max FD. So whatever is the max FD plus one we will be taking, and these all FDs, the select call will monitor for any activity. Okay. And we are putting this read FDs, all the read FDs of the client to monitor for this select. So if there is any activity on that, if it is greater than 0, so here if it is less than 0, it means select has some failure. Okay, and if there is some activity, if activity is greater than 0, it means we need to check if FD is set or not. Okay, so we have this server activity and read FDs. So we will check whether this file descriptor is being set in the read FDs or not. So is there any activity? So if there is any activity on this server, it means this is the listening socket of our server. Okay. So every client will first connect with our listening socket, and there they will connect with this accept system call, and it will create a new socket. Okay. So initially we will be connecting with the server FD, and once we get a new socket, what we will be doing, we will be putting this all new sockets in this client array. So we will be saving uh, this sockets file descriptor in this array. So we have 5 clients. So 5 clients we can save in this client I. Okay, and we will check if client I is 0. If it is 0, it means it's empty. We can consume it with our new socket, and then we'll break from here. So it will break from this loop. Okay, as we filled this client I, and here we will checking the all the clients if there is any activity on other clients as well. Okay, so how we will be checking it? So we will take this client I one by one, check if it is set. So anywhere, any client which is set, we will check for receive. Okay, so we will receive a buffer from that FD. So we will check all 5 clients, whichever we have. And by checking is set, it means is there any activity on that socket or not. So if there is no activity, it will not go inside this loop. So if there is an activity on that client socket, it means we need to receive it first, because this is the actually the intake model. So client will send and we will receive, and then we will send. So there is a flow of that. So if this value is less than 0, it means we need to disconnect that FD, because there is no value that is being sent, and here we will close this FD. So SD is here, and we will make that as 0 so that it can connect again. So there is some error in connection. Else, whatever we will do, if this value is not less than 0, it means we have some buffer. So buffer and the last value read, we will take a null and we will say client say this thing, and then we will send the buffer back to the same FD which we are receiving. So how it works for different clients is, once we have any activity on that FD, so it will go and check whether it is set or not, if there is any activity or not, and depending on that, it will receive and send out the data. It will echo back that data only. Okay. So I think you are clear with the flow. So we need to compile it and check if it works for our case or not. So for that, I'll check gcc hyphen o server and server dot c. So it got compiled. So we will also check what is on the client side. So I have client.c here. So similar to the last connect example which we discussed. So it's the same code, and what we are doing here, I'm just taking a while loop here. So what is a while loop? So if we let's start from the beginning. So we are creating a socket. Okay. Then we are creating this server address and port through which we can communicate. Okay. Here we have the IP address of the server, which we are able to connect from that. Or once it is this client got connected, it will be showing like this. So all the three-way handshake is completed till now. Then we will start with communication, and there is no point of connecting again because we already have this file descriptor, that new socket that is there in the server, and it will be monitoring only. So we will only send and receive the data. Okay, but this should be in the while loop because I am continuously sending the data through the client. Will write some data on that socket FD and reading from that. Okay, depending on that, we'll see this is the reply of that server or whatever, and we will take a 10-second of sleep so that this client will send the same data again and again to the server. Okay, and it will establish a connection like that. Okay, so what I will do here, client one, and I have client.c. I'll take two binaries from this because I need to connect to the same server. So I'll take two binaries, client one and client two, created from the same client.c, but the accept FD will be different for both the clients because they are connecting at different time. Okay, so they can communicate like that. Okay, so what I will do here, I will start the server first. Let's start the server. So TCP server listening on 9090 is here, and here I will launch client one. So once I launch it, socket created successfully connected to the server at 9090 port. Send hello from TCP client, and server is also replying back. Okay. So after 10 second, it is again sending hello from TCP client and server is again replying. So this way it continuously replying from the server. So if you see here, client 4 says hello this. So three times it's connecting. So after 10 second, it is creating this stuff. So let's try another client. So I will take another client. So once I do this, it is also connecting and it is also saying send hello world, hello from TCP client and server replying it. Okay. So if you see here, you will get two clients now. So new client connected by the FD4 and FD5. So these are being monitored by the select system call. So depending on the data which is being fired, because in our clients, we both the clients have 10 seconds of delay. So this way, both the clients are communicating simultaneously, which is not there in our earlier version. So if you see here, your server work more efficient when you use select system call. Okay, so this is all about this video. If you have any query regarding select, we can post a comment and we'll solve it. So let's see in the next video. Thanks.